Hello, everybody. Today is a very special day. It's 9/16/25. So you're probably wondering, Nick, what's so special about September 16th, 2025? Well, 9/16/25 is a Pythagorean Triple Square Day. So a Pythagorean Triple Square Day is a calendar date where the month is a squared, the day is b squared, and the last two digits of the year is c squared. And a, b, and c are natural numbers forming a Pythagorean triple. So the natural numbers are the counting numbers. So 1, 2, 3, and so on. And I'm not including 0 because the right triangle is not going to have a side with 0 length. So if a, b, and c are natural numbers, then that means a squared, b squared, and c squared are going to be perfect squares, right? So the month, day, and the year are going to be perfect squares. So first, I wanted to analyze the possible values of a squared, b squared, and c squared. So to ensure that we have a valid calendar date where the first two digits are the month, the next two digits are the day, and the next two digits are the year, we know that the month can only be a number between 1 and 12, right? January to December. So remember, the month is a squared and it's a perfect square. So the only perfect squares between 1 and 12 are 1, 4, and 9. So that means A belongs to the set 1, 2, and 3. So this symbol right here just means that A is an element of this set right here, 1, 2, 3. And the longest possible month has 31 days. So the day, which is B squared, goes from 1 to 31. But remember, it has to be a perfect square. So that means B squared can only be either 1, 4, 9, 16, or 25, which means B goes from 1 to 5. And for year, I'm saying it goes from 2 to 34 because remember, A squared plus B squared has to equal C squared. So the minimum A squared plus B squared value happens when A squared is 1 and B squared is 1. So that would make C squared 2. And the maximum A squared plus B squared value happens when A squared is 9 and B squared is 25. So the maximum C squared value is 34. Okay, and the only perfect squares between 2 and 34 are 4, 9, 16, and 25. So that means C is an element of this set, 2, 3, 4, 5. So I made a table checking all the possible values of A and B. And I computed A squared plus B squared, and I checked to see if it equals C squared for some C in this set. So this section is for A equals 1 and B goes from 1 to 5. This section is for A equals 2 and B goes from 1 to 5. And this section is A equals 3 and B goes from 1 to 5. I also have a column called A squared plus B squared. So that's C squared. And I'm trying to see if it's a perfect square, specifically that it's either 4, 9, 16, or 25. And the crazy thing is that only happens once. So it doesn't happen when A equals 1 at all. It doesn't happen when A equals 2. And it only happens when A equals 3 and B equals 4. You have C squared is 25, which means C is 5. So yes, this is the only Pythagorean triple where A, B, and C are natural numbers satisfying the equation A squared plus B squared equals C squared. So that means A squared is 9, B squared is 16, and C squared is 25. So this means that the only possible Pythagorean triple square day under normal calendar rules is 9/16/25, and it comes from the Pythagorean triple 3, 4, 5. So that means this is your only chance to celebrate a Pythagorean triple square day. Enjoy it while it lasts, unless you live another 100 years, because the next time this is going to happen is 9/16/21/25.